Hi, I am B. Janardhan Reddy. In the previous video, it was shown that the current drawn from the source is equal to the sum of the currents drawn by the different branches, say resistors, in a circuit. That is, in the previous video, it was shown that I is equal to I1 plus I2 plus I3. Now in this video I am going to show you the parallel connection of resistors and derivation of a formula to find the equivalent resistance of the parallel connection of the resistors. Okay? Equivalent resistance of a parallel connection. When the resistors say R1, R2 and R3 are connected in parallel between the points A and B in such a way that the same potential difference is applied across each resistor, then the reciprocal of the equivalent resistance is equal to the sum of the reciprocals of the individual resistances. That means 1 by R is equal to 1 by R1 plus 1 by R2 plus 1 by R3. So in this video, we are going to derive a formula that is 1 by R is equal to 1 by R1 plus 1 by R2 plus 1 by R3. Here R is the equivalent resistance of the three resistors whose resistances are R1, R2 and R3. So three resistors having resistances R1, R2 and R3 are connected in parallel, then the reciprocal of the equivalent resistance is equal to sum of the reciprocals of the individual resistances. That we are going to derive in this video. Okay? Now let us see how the resistors are connected in parallel. Parallel connection of resistors. In the parallel connection or combination, one end of each resistor is connected at one point say A and the other end of each resistor is connected together at the other point say B. The battery along with a key K is then connected in between the points A and B as shown below. See here. Here are the 2 points between which I am going to connect three resistors whose resistances are R1, R2 and R3 respectively. Point A, here is the point B. Between these 2 points I am connecting three resistors. This is the first resistor whose resistance is R1. And this is the second resistor whose resistance is R2 and here is the third resistor R3. So these three resistors have been connected in parallel between A and B. So you can observe here when the resistors are connected in parallel, current finds more than one way. Here current passes from A to B in more than one way. If one resistor gets damaged, current will not stop in the circuit. Okay, so there is a more than one way between A and B to pass the current. Now I will connect these 2 points to the battery along with a key. See here, this is a battery, this is the positive terminal and this one is the negative terminal. I am connecting the point A to the positive terminal through a key and the negative terminal has been connected to the point B. So this is the parallel combination of resistors. Okay, and here the switch is in half position. That's why the circuit is kept open. Hence no current is flowing through the circuit. Okay. Now I will close this circuit by turning the switch on here. What happens then? Let us see here. If the circuit is closed, the current I drawn from the battery divides itself at the point A in three parts. I1 in resistor R1, I2 in resistor R2 and I3 in resistor R3. So if I close the circuit by turning the switch on here, what happens? You see here. Yes, here current is flowing in the circuit. Now you observe carefully here. I current is drawn from the source, that is from the battery. So this is the total current of the circuit. So the total current I gets divided into three parts at A. The current is splitting, and some current, say I1 current is passing through R1, I2 current is passing through R2 and I3 current is passing through R3. So depending upon the resistance of the resistor, current passes through it. So the total current of the circuit I gets divided at A, and these divided currents pass through R1, R2 and R3. Again these three currents will join at point B and it becomes equal to the total current of the circuit. Okay. So this is the parallel combination of the resistors. When the resistors are connected between the 2 points, say A and B, in parallel, isn't it? So the total current drawn from the battery will get divided, and different current flows through the different resistors, and all these currents again will join at point B, and that will become as the total current again. Okay. Now let VA and VB be the potentials at the points A and B respectively. Then the point A connected to the positive terminal of the battery is at a higher potential than the point B. That is, VA is greater than VB. So here in this circuit I have shown the direction of the conventional current only. The direction of the conventional current is always from positive to negative. Actually the electrons are flowing opposite to the direction of the conventional current in these wires. Okay, so when the current is flowing from positive to negative terminal, means that the positive terminal of the battery is at higher potential than the negative terminal of the battery. Okay, so here let VA is the potential at point A and VB is the potential at point B, and obviously we can see that VA is greater than VB because point A has been connected to the positive terminal of the battery, whereas point B has been connected to the negative terminal of the battery. Okay, so what is the potential difference between A and B? It is VA minus VB. So the main important point to be noted here, The potential difference between A and B is VA minus VB. That is, across each resistor the same potential difference is applied, but the currents flowing through them are different. See here, the potential difference across each resistor is V is equal to VA minus VB. Across the resistor R1, V voltage has been applied. Across the resistor R2 and R3 also the same potential difference has been applied. Okay, even though the same potential difference has been applied across each resistor, the currents flowing through them are different because of the different resistances they are having. Okay. Now, according to Ohm's law, let us find the current I1, current I2, current I3. So, according to Ohm's law, you see here, current through R1 is I1. Let I1 current is flowing through R1. So, how much potential difference has been applied across the resistor R1? It is V. That is VA minus VB. We let it as V. That V is nothing but the potential difference between the terminals of the battery. So the total voltage of the battery has been applied between A and B. So current through R1 is I1. This is equal to V by R1. The same way, current through R2 is I2 is equal to V by R2. You know, current in a resistor is inversely proportional to its resistance. When the resistance is more, less current flows. When resistance is less, more current flows. So depending upon the resistances here, the current flows through them. So current through R2 is I2. This is equal to V by R2. According to Ohm's law only, I am writing all these things here. Current through R3, let us say it is I3 V by R3. So I1 is equal to V by R1, I2 is equal to V by R2, I3 is equal to V by R3. V is same for all the resistors. Okay. Now I will add these three currents, I1, I2 and I3. I1 current is flowing through R1. It is I1 is equal to V by R1 and I2 is equal to V by R2. Just now we have seen their values according to the Ohm's law, isn't it? So I will sum up these three currents because the total current drawn from the battery is getting divided into three parts. At point A, and I1 current is flowing through R1 and I2 current is flowing through R2 and I3 current is flowing through R3. Again, these three currents will join at point B and flows as the total current in the circuit. Okay, see here, on adding these currents, you have seen just now the values of I1, I2 and I3 according to the Ohm's law. I will bring back the same board once again. You see here, according to Ohm's law, current through R1 is I1 and current through R2 is I2 and current through R3 is I3. These are their values. I will just sum up these three values here. I1 plus I2 plus I3 is equal to V by R1 plus V by R2 plus V by R3. Okay. Now, I am going to remove all these three resistors. In place of them, I will connect a single resistor between A and B whose resistance is equal to the given three resistors. That means if I remove these three resistors, if I connect a single resistor, the same current flows in the circuit. These three resistors are drawing some current, say I, from the battery. If I remove these three resistors and I will join a single resistor, that also draw the same current from the battery. Okay, so first turn the switch off here. Let R be the equivalent resistance between the points A and B. That means I am going to join a single resistor between A and B whose resistance is equal to the given three resistances. So first turn the switch off here, then circuit has been opened, so no current is flowing in it. Now let us remove these three resistors. So here between the points A and B I will join a single resistor whose resistance is R. That is the equivalent resistance of the given three resistors. Okay, so R is the equivalent resistance of the three resistors, and let us turn the switch on. Now I current, same current is flowing through the resistor. Okay, so according to Ohm's law, you can see here how much potential difference has been applied between A and B here. It is nothing but V. Here is VA, the potential of A is VA, and at the potential B it is VB. VA minus VB is nothing but V. That is the potential difference between the two terminals of the battery. So V potential difference has been applied between A and B, and how much current is flowing through the resistor R, let us find here. According to Ohm's law, I is equal to V by R. So here R1, R2, R3 are the individual resistances, and R is the equivalent resistance of these three resistors. Okay. Now you can see the two circuits, and this circuit is equivalent to this circuit only. Whatever the current is flowing in this circuit, I current is flowing. The same current I is flowing in this circuit. The only difference is that here three resistors have been connected between A and B, whereas between A and B only a single resistor whose resistance R is connected. So the resistor R draws same current I from the battery as these three resistors are drawing the same current I. Okay, see here, but that means here I is equal to I1 plus I2 plus I3. Why? Because the total current of the circuit drawn from the source is getting divided into three parts, I1, I2 and I3, and they are joining at point B. So I is equal to I1 plus I2 plus I3. Just now we have seen these values, I value and some of these currents values. Let us see once again here. See here, I1 plus I2 plus I3 is nothing but V by R1 plus V by R2 plus V by R3, whereas I is equal to V by R. So let us substitute these values in this equation. We get V by R. I is how much here? V by R. I1 plus I2 plus I3. The sum of the currents we got as V by R1 plus V by R2 plus V by R3. Okay, so this equation can also be written as, I am taking V as common in this, V into 1 by R is equal to V into 1 by R1 plus 1 by R2 plus 1 by R3. On both sides V will get cancelled. You see here and we left 1 by R is equal to 1 by R1 plus 1 by R2 plus 1 by R3. 1 by R is equal to 1 by R1 plus 1 by R2 plus 1 by R3. This is the required formula in case of parallel connection of the resistors. Here I have taken only 3 resistors, and we can take as many resistors as you want, and the formula only will be extended like plus 1 by R4 plus 1 by R5 like this. Okay, so in this formula, R is the resultant or equivalent resistance of the resistors R1, R2 and R3 which are connected in parallel. Thus, in the parallel combination of resistors, the reciprocal of the equivalent resistance is equal to the sum of the reciprocals of the individual resistances. So in case of parallel connection, R is not equal to R1 plus R2 plus R3. Here the reciprocal of the equivalent resistance is equal to sum of the reciprocals of the individual resistances. Okay. Thank you.